flying field at Farnborough, with the British aircraft industry on show. Unconventional new aircraft are appearing for the first time. But let's look first at those that are more familiar. The Blackburn and General aircraft freighter GAL-60 has been improved with a bogie main undercarriage. This giant transport can now land safely on 300 yards of grass. The Airspeed Ambassador is now in full production. This British European Airways machine has two Bristol Centaurus piston engines, but a design study has been prepared for development with propeller turbines. The Vickers Viscount 700, with its four Rolls-Royce Dart propeller turbines, is not only on order for British European Airways, but also for Air France and Aer Lingus. A new development of the long-established Gloucester Meteor is the private venture ground attack fighter. With this machine, Jan Jurakowski demonstrates the first entirely new aerobatic for 20 years, cartwheels. He climbs vertically, then loses speed and shuts down one of his Derwent engines. When he shuts down the second engine, the load on the wings keeps the aircraft cartwheeling. This load is made up of rockets as well as wingtip fuel tanks. Outstanding flying, too, comes from 54 Squadron Fighter Command with de Havilland Vampires, a demonstration of perfect controlled flying with jet aircraft. A de Havilland Venom shows the progress made with reheat or afterburning. The flame is visible as the large quantities of additional fuel burn in the jet pipe and thrust the aircraft forwards. Here is an aeroplane making its first public appearance, the de Havilland Sea Venom. Not only can this high-speed two-seater aircraft operate from an aircraft carrier, but with its radar and navigational aids, it can fly in all weathers. The Vickers Supermarine 535 has been seen before, but its successor, the Swift, with the more powerful Rolls-Royce Avon engine, is to become one of the first Royal Air Force British swept-back wing fighters. Another is the Avon-engined Hawker 1067. Few doubt that Neville Duke exceeded the official world record speed of 671 miles an hour. At this speed, the sudden change in pressure over the wing can create its own storm of rain. Twin Avon engines are fitted to the Vickers Supermarine 508, the world's most powerful carrier-borne naval fighter. The unconventional design aims at the very wide speed range required for naval operations. The English Electric Canberra has had a year of steady development and dramatic successes with its record Atlantic crossings. The PR3 is a new variant for photographic reconnaissance. This Canberra is an experimental version with Armstrong Siddeley's Sapphire engines, the engines that will be used in the American version. Dramatic progress has been made with completely new designs of large aircraft for high speed. The short SA-4 bomber has a large capacity and a crew of 5. In spite of a considerable wing area, it's designed to fly very fast by using an extremely thin wing. This is helped by mounting the 4 Avon engines in pairs, one engine above the other. An entirely different solution to the problem of designing large aircraft that can fly very fast is seen in the Vickers Valiant. The 4 Avon engines are buried in the roots of a much thicker wing. The drag at speed on the large, thick wing is kept down by sweeping it back. A substantial order of Valiant bombers has been placed for the Royal Air Force. Most dramatic of all are the aircraft of the future, the Delta Wing high-speed research aircraft. The Boulton Paul P111 has a Rolls-Royce Nene engine. Few details are available about these new and exciting aircraft, but Delta wings have advantages in high-speed flight, apart from the absence of a tailplane. Wings with a low aspect ratio, that is short, wide wings, behave better than long, narrow wings, as the speed of sound is reached and passed. High-speed flight calls for high-speed landings with small, streamlined aircraft. A parachute brake helps to slow down this machine. The Avro 707A, another Delta, has a Rolls-Royce Derwent engine with air intakes in the wings. The Delta wing permits a considerable wing area in spite of a small span. And the greater the wing area, the better the performance in the rarefied air at high altitude. The Avro 707B is a so-called low-speed version of the 707A. It's known that while Delta wings have advantages at high speeds, they may be less satisfactory at low speeds. Because of the sweep back, the wings may behave violently if the tips stall, and a low aspect ratio may also make low speed control difficult. Roly Falk showed how far our research has gone to overcome the disadvantages of these new wing shapes. There are no flaps, but the dive brakes in the middle of the wings produce drag roughly equal to twice that of the aircraft. In the years ahead, we may well look back at 1951 as the time when we first proved that we were solving the problems of designing aircraft that will fly equally well both below and above the speed of sound.